This is the third video. We are still on lesson 7-1 and I am on page 455 at the bottom. And we are looking at the properties of proportions. So let's take a look at this. The proportion A over B equals C over D is equivalent to the following. And then we're going to look at the same thing done with numbers instead of variables. So I want you to work hard to follow me on this. We are going to do some algebra, and I'm going to turn my book so that you see that, but so that you can also see me writing easily. So what I want you to see is that there are a number of ways for us to make this statement, and they all mean the same thing. We can say AD equals BC, and that is simply our cross products property. So I cross multiplied AD, and I got AD, and I cross multiplied BC, and I got BC. So AD is equal to BC. This can also be written basically upside down as B over A equals D over C. And this is where I want us to look at a little bit of algebra. So I'm going to rewrite the original one. A over B equals C over D. And I want you to see what happens when we do some finagling algebraically. So I am going to start by moving this B. Now remember, when we have something on the bottom of a fraction, we can multiply by it on both sides of the problem to cancel it over here. So let's say times B, and let's multiply by B over here, because whatever we do to one, we have to do to the other. One side, we have to do to the other side. So our B's canceled, and now we have A equals CB over D. Now this is going to take just a few minutes, so y'all be patient here. I just want you to see that this is all algebraically based, that we're not just randomly rearranging an equation. Okay, so now we want to get D on top right there. So now we've got to multiply both sides of the problem by D. And again, we're going to cancel those. Now we're going to have DA equals CB. Okay? Now, if we come back, we see that we want the C on the bottom and the A on the bottom. So if we if we divide both sides of our problem by C, then C under here is going to cancel, and we will have DA over C equals B. Now, one last thing, we need to get our A on the bottom under the B. So let's divide both sides by A. When we divide this side by A, it will cancel. And then when we divide this side by A, we'll be left with B over A. So we have D over C equals B over A. That's exactly what our equation told us. So we basically, just by looking at this, we simply flipped it. And in the future, you'll know that algebraically that's safe to do. But I showed you the why of why you're able to do that. Now, before we can keep going, I'm going to erase all of that so that you can see the next step with me. And after this, what we're doing won't take long. I just want to make sure that you see the foundation of this. Okay, so now let's look at our original one or the second one and see how we got here. Well, if we go to our original one, you can see that we just divided both sides by C, and that's how we ended up with C on the bottom over here and canceled out over there. And we divided both sides by D, canceled out on this side, and came to this side. So that's how we got A over C and B over D. All right, so now what I want to show you is when we do it numerically, it works the exact same. We would use the exact same algebra to do that. And 1 to 3, or 1 is to 3 as 2 is to 6 can be multiplied. 1 times 6, cross multiplied of course, and 3 times 2. So 1 times 6 equals 3 times 2. Is that true? Yes, you can see that 6 on this side is the answer and 6 on this side is the answer, so they are in fact equal. Now let's look at it here. They flipped it, of course, using the same algebra pattern that we used on the other side. So 3 over 1 is the same as 6 over 2. Is that true? What's 3 divided by 1? It's 3. What's 6 divided by 2? It's 3. So this is an equivalent equation. We have 3 on one side and 3 on the other. And lastly, when we rearranged it again, algebraically, of course, not just randomly, we have 1/2 is equal to 3/6. Well, 3/6 is 1/2. So again, it's equal, and again, that makes sense. All right, I'm just going to do a tiny bit more erasing right here, and let's flip the page. Okay, so now we're going to use what we just talked about in an example. This is example 4 at the top of page 456, and I'm going to scoot through this quickly because that last part took a good bit of time. So using the properties of proportions, we're going to solve. Given that 4x is equal to 10y, find the ratio of x to y in the simplest form. So we're going to find out what the numerical ratio is, and then we're going to simplify because they want it in the simplest form. And we talked earlier in the lesson about our ratios always needing to be in simplest form anyway. So we have 4x equals 10y, and the book gave us a message about this. Since x comes before y in the number sentence or the math sentence, x will be in the numerator of the fraction. So you can see x came first, so we're going to put x on top and y on the bottom, which simply means we divided both sides by y. So on this side it canceled, and on that side we were left with it. So we have x over y, and then you know what, I don't think I ever finished explaining the top part. Oh no, there's nothing to explain there, I'm sorry. Okay, so now we keep simplifying, and in order to get our variables both on the left side, we're going to divide both sides by 4, and we're going to have x over y equals 10 over 4. When we divided the left side by 4, it canceled, and it was left on the right side. So algebraically, if you're not sure about that, pause the video and look at what we did. It's the same algebra that we've been doing all year in geometry, just following our usual algebra rules. But we needed to get our numbers all on one side so that we saw the actual ratio. And now we can see that xy, which is 10/4, reduces to 5/2. Okay, so that is our simplest form of this ratio, x to y. Now, because they told us the ratio is x to y, that told us also the order that we needed them in, x on top, y on the bottom. If we had flipped it, everything would have to flip. But then our final ratio would not be in the x to y form. If we had flipped everything, then it would have been in the y to x form, which we will see in our next example. So this is the check it out. And it says, given that 16s is equal to 20t, find the ratio of t to s in simplest form. Now you notice the equation gives us s first, and the note beside the last example told us that we should put that in the numerator of the fraction, the top of the fraction, because it came first. However, what contradicts that is the fact that they want the ratio backwards to the order that they presented the variables. So they presented s first, but they're asking for t to be first. Be attentive to that in your problems. That actually messed me up big time when I was studying this lesson yesterday, and I overlooked that and could not figure out why in the world my answer did not match the answer in the back of the book. So make sure you're attentive to the order that they are requesting. So in this case, t is going to need to be in the numerator. So let's work through this. Even though I've already done it, I want to do it in a way that you can see, because actually things are going to be on a different side doing it this way. So 16s equals 20t. Now we want t in the numerator, so we're going to divide by s on both sides to cancel s from this side and to get s under the t. We're also going to divide both sides by 20, so that the 20 is under the 16. Now that's where you can see that we have t over s equals 16 over 20. And I'll bring you back over here because that's what I had done. I just had them on different sides. T is to s as 16 is to 20, or t over s equals 16 over 20. Now we have our ratio of t to s with t coming first, but we must simplify. So 16/20 simplifies to 4 over 5, or 4 to 5. All right, we have one last problem. This is a super long video, and I apologize. It's going to be like 10 minutes, a little bit more, but let's run through this problem really quickly. During the filming of The Lord of the Rings, the special effects team built a model of Sauron's I have no idea if I said that right. Soren's tower with a height of 8 meters and a width of 6 meters. If the width of the full-size tower is 996 meters, what is its height? So we're going to make a ratio. We've got to make sure that we're always comparing apples to apples. So in other words, the like things have to hold the same places in the fractions. So in this case, we're solving for height, and we have our ratio of the model, which is a height of 8 meters. You can see that height of 8 meters and a width of 6 meters. And then we don't know the height of the actual tower, the full-size tower, but we do know its width. So our proportion is 8 to 6, or 8 is to 6, as what is to 996. What x is going to allow the right side of the proportion to have the same relationship as the left side of the proportion? So we're going to cross multiply, of course. 8 times 996, and you can see that I've done that right here, and the answer is 7,968. And then I'm going to cross multiply 6 times x. So we have 7,968 equals 6x. Divide both sides by 6, and x equals 1,328 meters. Okay, then we lastly have a check it out. Suppose the special effects team made a different model with a different height. This time the height is 9.2. The width is still 6. And what is the height of the actual tower? So we still have our same width of the actual tower and our same width of the model, but our height of the model changed to 9.2. And of course that means that proportionally the height of our actual tower is going to have to change too. So again, we cross multiply. You can see that I've done that right here and left off my parenthesis. I know y'all would be begging for candy if we were in class and you saw that. All right. So we have 9.2 times 996. Here's the final product there. Let's see. And then we have 6 times x, which equals 6x. And we divided both sides by x. I'm looking to see what I've done, guys. Give me just a second. I think I jumped ahead of myself here. Give me just a sec to undo this. Okay, the 9163.2 was equal to 6x, and then we had to divide both sides by x. I cannot access my calculator while I'm doing this, so I cannot give you that final answer, but you are welcome to do the math and look it up. And that is it. I will have homework assignments posted, and I hope y'all have a great Monday. See you Tuesday.